Okay, so in this video we're going to look at how to find an equation of an ellipse, right, with given information, right? So uh, really any information that you're given, we'll approach it the same way, right? So in this case, so they're asking us, what is the standard form of the ellipse that has vertices -3, 3, 5, 3, and foci 1 minus 2 root 3, comma 3, and 1 plus 2 root 3, 3. A good place to start with this is, let's just plot these points. Right now, right away, I could see that it's going to have a major axis along the horizontal, along the x-axis. Right now, again, how do I know that? Well, by initially just looking at the values of these vertices, right? Notice that the y-coordinate is fixed, so the horizontal coordinate is fixed, and it moves along the horizontal. And you'll see that, right? If you don't see that right away, that's why I always suggest just draw what you have, right? Before we even try to do anything, I think it's important to just kind of visualize what it is that we're looking for, right? Very important step here, in my opinion. So if this is 3, have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so the values here of our vertices, and again, when we say vertices, those are the ones along the major axes. The co-vertices are the ones that are along the minor. So -3, 3, so somewhere around here, and another one is 5, 3, so somewhere along here. Okay, so this is my major axis. Okay, and the length of it, right, the length of my major axis, 2a, right, I'm going to take the absolute value because it's a length, so that value is always positive. So take the right endpoint, 5, minus the left endpoint, which is -3. Right, so here, right away, we get one of the values that we're looking for, that's -8. Drop the absolute value, we get +8, divide by 2, we get a is 4. All right, so nice. Right off the bat, we get this value here. All right, now these vertices or these foci here, they're somewhere along here. I did this previously along in my calculator. So this is 1 minus 2 root 3, comma 3. And then again, just kind of estimating where they are. And again, this is mainly just for me. I like to kind of look, make sure that I know what I'm looking at here. Okay. All right. And one other thing I know is actually know the center already. Right? If A is 4, that means kind of reverse, working backwards here, right? The distance between the vertex here and the center is 4, right? Because the whole thing is 8, 2A, right? Half of it is 4, so working my way back, 1, 2, 3, 4, right? And of course, it's going to be on the axes, the major axes here. So I already know my center actually here. My center is going to be 1, comma 3. Okay, so see how a lot of these start kind of showing up really now. We did go over those kind of formulas for these vertices and co-vertices, and maybe that when you see that, you're like, all right, that works for me. I like doing that. For me, I like to stick to just drawing stuff out, right? I don't need to worry about memorizing all of those formulas here. All I need to know is the equation of an ellipse, which that I have memorized by now. But again, easily looked up if you don't have it memorized at this point here. Okay, so I have the center. I have my values of A. I don't have C, right? I know where the foci are, but I don't actually know the values of C. So the value of C would be this distance here, right? And again, C, it's a distance, so we'll take the absolute value. Right endpoint, 1 plus 2 root 3, minus left endpoint, which is 1, right? Again, because we're moving only along the horizontal. All right, so the 1 cancels out, and we're left with absolute value of 2 root 3, but I can just write it as 2 root 3 since it is a positive value. I can just drop the absolute sign. All right, we're cooking here, right? I think only thing I got left here is to find the value of b, but I know that c squared is equal to a squared minus b squared. Okay, that's how I relate a, b, and c. Okay, so now plugging values in. 2 root 3 squared, a is 4 minus b squared. Okay, so squaring these, right, this is a product, so you square each one of these individually. 2 squared is 4, square root of 3 squared is 3. And this is 16 minus b squared. Okay, so we get 12 equals to 16 minus b squared. All right, solving for b squared, we get b squared is 4. And I really don't need the value of b, right? It's 2, but I just need the equation. So right away, I know my equation is going to be x minus 1, right? The x value of the center squared over a squared, right? The major axis, right? The major axis is 4, so 4 squared is 16, plus here we'll have y minus 3 squared, and b squared is 4, and always equal to 1. And there we have my equation. All right, and that's how you find the equation of an ellipse with given information here.